Alright, so good night everyone, let us get started. Okay, so tomorrow is the Addmath exam, and what I want to do is just to quickly look at some common questions that you can see in the exam paper tomorrow. We know that they repeat a number of questions, so I want to just go through some questions, common questions that we see regularly in the exam, and let's hope that those questions will be there tomorrow and you'll be able to answer them comfortably to put you in a good position to pass your Addmath with an excellent grade. Okay, so let's get started. So looking at first questions on remainder, factor theorem, quadratic equations, quadratic inequations. That's what you normally see in terms of the order and format in the paper. So we have here the expression x minus 2 is a factor of. So if x minus 2 is a factor, it means the remainder, when I divide x minus 2, which is your divisor, into any one of these polynomials, which is your dividend, my remainder should be 0. So which one of those will give me a remainder of 0? So let's try the first, a. So if I let f of x be equal to 4x to the power of 4 minus 2x squared subtract 56 to determine if x minus 2 is a factor, I'm going to let x minus 2 be equal to 0, and therefore x is equal to 2, and if I substitute 2 into this polynomial, I'm supposed to get 0, and once I get 0, it means that x minus 2 is a factor of that polynomial. So therefore f of 2 becomes 4 times 2 in brackets raised to the power of 4 subtract 2, I'm going to put 2 in brackets squared minus 56. 2 to the power of 4 will be 16. 16 by 4 is 64. Subtract 2 squared is 4. 4 by 2 is 8. So of course we have negative 8. Subtract 56. 64 subtract 8 will give us 56. And 56 minus 56 will be 0. So the answer for this question is E. Right, let's look at question 2. The expression AB plus 3C minus 3B minus AC is equal to, it's a simple case of factorizing. So we have AB plus 3C minus 3B minus AC. So we have 4 terms. So once you have 4 terms, you're going to use the method of grouping to factorize it. So I'm going to, what I can do here, I can rearrange where I will have 2 pairs and each pair will have something common to it. So when I rearrange, I'm going to rearrange by putting AB plus, AB minus 3B. So I'm going to rearrange grouping these two together, and I'm going to group negative, but I'll group negative AC plus 3C together, because I want to maintain that order, A, right, A first, and of course 3 comes after. So I'll put negative AC first plus 3C after. So I'm going to factorize. I'm going to divide it into 2 pairs because I have 4 terms, 1, 2, 3, 4. So I divide into 2 pairs. I'm going to factorize each pair now that I have something common to each pair. I have a term or a factor common to each pair. So if I look, B is common to the first pair. So when I divide B into AB, I get A. When I divide B into negative 3B, I get negative 3. Let me factorize my second pair. The sign controlling the first term of the second pair, I bring down automatically. And C is common to my second pair. So negative C will be my highest common factor, which I'm going to divide now into each term. So negative C into negative AC gives me A. And negative C into plus 3C will give me negative 3. So I have A minus 3 common to same expression within each bracket, so I've established something common, and now I can further factorize by taking out A minus 3 as my common factor, and B minus C will be the other bracket. So therefore my answer here will be A minus 3 and B minus C, whose answer here is C. Right? So the answer for question, the second question here will be C. Let's move on to the third. It says here, given that x plus 2 is a factor of this cubic polynomial, then p is equal to, what is p equal to? So if x plus 2 is a factor, it means automatically that when I divide x plus 2 into this cubic polynomial, my remainder is 0. Automatically, the remainder is 0. And if you have to solve for an unknown quantity, you have to establish or create an equation. So we can create an equation here by simply saying, if f of x is equal to 2x cubed minus 3x squared minus 5x plus p, seeing that x plus 2 is a factor, I'm going to let x plus 2 be equal to 0, and therefore x will be equal to negative 2. So when I substitute x equal to negative 2, I substitute negative 2 for x in my cubic polynomial. I'm supposed to get a remainder of 0 because x plus 2 is a factor. So therefore, I can simply say now f of negative 2 will be equal to 0. Meaning, when I substitute negative 2 into this polynomial, I'm supposed to get 0. So I can, of course, I have basically created an equation here to help me to find the p. So this becomes 2 negative 2 in brackets cube minus 3 negative 2 in brackets squared, subtract 5, negative 2 in brackets, plus p is equal to 0. So let's solve to find the p now. So negative 2 cubed will be negative 8. Negative 8 by 2 is negative 16. Negative 2 squared is 4. 4 by negative 3 is negative 12. Negative 5 by negative 2 is positive 10. Plus p is equal to 0. So we're going to get here negative 16 subtract 12 will be negative 28 plus 10 plus p is equal to 0. We know negative 28 plus 10 will be negative 18 plus p is equal to 0. And therefore p is equal to positive 18, whose answer there is C. Alright, so we're showing that if we see these questions tomorrow, we can comfortably answer those questions and work towards getting that distinction in our Addmath. So let's move on to the next. Right. So another very common question. Which of the following best describes the function f of x is equal to x into 1 minus x? So when we expand this expression here, when I remove my brackets, I'm going to get f of x can also be expressed as x minus x squared. Now this here is a quadratic expression because I have a variable raised to the power of 2. And once a number in front of my variable squared, x squared in this case is negative, I know automatically when I sketch, my curve is one that is concave down. So I'm going to have a maximum turning point. So to sketch, what we need basically, if you look at the options for answers, we see where we have our shape curve and we see where the curve will cut the x-axis at 2 points. So for us to get those 2 points where the curve cuts the x-axis, it requires us to solve a quadratic equation. So I'm going to let x into 1 minus x be equal to 0. This is a quadratic equation. Remember, x minus x squared, when I expand the brackets, is a quadratic expression. So of course the quadratic expression placed equal to 0 makes it a quadratic equation. And of course the expression is already factorized, so I can say either, let me get my 2 roots, my first factor x I place equal to 0, and or my second factor 1 minus x I place equal to 0, negative x is equal to negative 1, and therefore I can divide both sides by negative 1. Negative 1 is understood in front of x, and therefore x is positive 1. So therefore we know that your curve will be concave down, but the roots are 0 and 1, so we're looking at this. Alright, whose answer is B. So the answer is B for that question. Okay? So let's move on to the next. If x squared minus 6x plus 13 is equal to a into x plus h in brackets squared plus k, then what is a, h, and k? So this basically is completion of squares. So we have here the quadratic expression x squared minus 6x plus 13. And if we have to find a, h, and k, then simply we know that there's a formula for h and there's a formula for k that can help you, that can quickly help us to determine h and k. So we know that the number in front of x squared is 1, which is a. The number in front of x is negative 6. The coefficient of x, which is negative 6, that represents b. And the constant 13 will represent c. So in order for us to find h, already we know a is 1. In order for us to find h is equal to the formula b all over 2a. So I'm going to replace b with negative 6 over 2. I'm replacing a with 1. Negative 6 over 2 gives me negative 3. So I know h will be equal to negative 3. And k will be 4ac minus b squared all over 4a. So I'm using that formula to help me to find k. So this will be 4, I'm replacing a with 1 in brackets, I'm replacing c with 13 in brackets, subtract, I'm replacing b with negative 6 in brackets all squared, all over 4, I'm replacing a with 1. This becomes 4 by 13 will be 52, subtract, negative 6 squared will be 36, all over 4, so we know 36 from 52 will give us 16 all over 4, so we know k is equal to 4, so therefore we can come put up, we say here a is equal to 1, h will be equal to negative 3, and k will be equal to 4, whose answer is B. So a is 1, h negative 3, k 4. So let's move on to the next. So common questions we can see, and let's make sure we have an understanding of these questions. So let's look at the next. We have, right, so we want us to determine what are the roots of that equation. That is a quadratic equation. So the quadratic equation is 3x squared minus 6x minus 5 is equal to 0. And for us to determine the type of roots, of course, we're going to use our discriminant to help us to do so. The discriminant d is b squared minus 4ac. And let me substitute for b, a, and c in my discriminant. And based on my substitution, I'll know what type of root we're going to obtain from solving this. What type of roots we're going to obtain from solving the quadratic equation. So I'm going to let a be the number in front of x squared, which is 3, b be the number in front of x, which is negative 6, and c is the constant, which is negative 5. So I'm going to substitute for a, b, and c into my discriminant. So d is equal to, I'm replacing b with negative 6 in brackets squared, minus 4, I'm replacing a with 3 in brackets, I'm replacing c with negative 5 in brackets. So I'm going to get negative 6 squared will be negative 6 by negative 6, which is positive 36. Negative 4 by 3 is negative 12. And negative 12 by negative 5 is plus 60. So I know 36 plus 60 will give me 96, which certainly is greater than 0. So the discriminant is greater than 0, which will tell us what is greater than 0. It will tell us the roots are real and distinct. Once this happens, once the discriminant is greater than 0, so we know that our answer here is B. So again, common questions we can see in the examination. So let's move on to the next. Right, so the values of x of which x plus 15 in brackets squared is equal to 64x. Now, this here is a quadratic equation. If we expand it, clearly we're going to establish a quadratic equation. But of course, in solving this, you know, we're looking at time. It's an Addmath exam. We're looking at time, and you know, we want to determine what values can help us to obtain. What are the values of x that can be obtained when we solve this quadratic equation, right? And the values of x by simple process will be to take our options, all our options, and we substitute into the equation to help us to determine if those options satisfy the equation. Okay? Now the answer here is D, which is 9 and 25. And to prove and show where we can use simple substitution to help us to quickly get the answer. Now, of course, we can solve the quadratic equation using the long approach, which I can do, but in just of time and on the exam conditions, we know that using the short approach can help us. So when x is 9, if I replace x with 9, look at what's going to happen. 9 plus 15 in brackets squared is equal to 64 times 9. Right? So 9 plus 15 will give us 24. And 24 squared, that's 24 by 24, that gives me 576. And of course 64 by 9 also gives me 576. So it shows when I substitute 9 into my equation, it satisfies the equation, because what is on one side is equal to what is on the other. So clearly 9 satisfies the equation. Let's try 25. So when x is 25, this will be 25 plus 15 in brackets squared is equal to 64 times 25. So we know 25 plus 15 is 40. 40 squared, of course, we know that's 40 by 40, that's 1600. And we know 64 by 25 also gives us 1600. So when I substitute 25 into my equation, it satisfies the equation because what is on the left is equal to what is on the right. So automatically my answer here will be D. So this is a short approach. The long approach will be to solve the quadratic, which will give you the same results. Alright? So let's move on to the next. So if you see this question in the exam, this is what we can do to, or something similar, this is what we can do to find the values. Okay? So let's move on to the next. Right, so another common question. It says here the number of visas B to X issued by an embassy annually is given by that quadratic expression. The least number of visas is issued in a particular year is. So we have V to the X is equal to 7x squared minus 42x plus 72. And if we have to determine the least number of visas issued, what it requires us to do is to compute the square. We have to convert this into the form a into x plus h all squared plus k, where k is what you call the minimum value of the quadratic. This is a quadratic function, and k is the minimum value. This is your turning point. K is the minimum. In this case, we're looking at the least number. So k is the minimum value of the quadratic function, which will also represent the least number of visas issued in a particular year. So what we need to do is to convert this quadratic expression into that form, and k will be our least number of least number of visas issued in a particular year. So let's complete the square. So you have 7x squared minus 42x plus 72. So of course, to complete the square, I'm using the formula approach. So a is equal to 7, b is equal to negative 42, and c is equal to 72. So to find h, I'm using my formula b over 2a. So b of course will be negative 42 all over 2 times 7. So that is negative 42 all over 14, and negative 42 divided by 14, that will give us negative 3. And k will be 4ac minus b squared over 4a. So please make sure you know the formula when you complete the square. Very quick, easy method of obtaining ah and k. So this will be 4 times a, which is 7, c, which is 72 in brackets, subtract b, which will be negative 42 in brackets squared, all over 4 times a, which is 7. So I'm going to get 4 by 7 by 72 gives me 2016, subtract negative 42 squared will be 1764 divided by 28. So 2016 subtract 1764 gives me 252 divided by 28 gives me 9. So k is equal to 9. And if k is equal to 9, then it means that that will be the least number of visas issued. That's k. So the answer here is B, which is 9. Okay? So every time you ask to find the least number, you're given a quadratic expression, you have to complete the square to help you to determine what's the value. Okay, so let's move on to the next. So another common question, expressed as a single fraction, we have 1 all over x plus 3 all over x squared minus 9. So first to obtain a result for this, 1 over x plus 3, x squared minus 9, we know we can't factorize that. That is the difference of two perfect squares. This is x plus 3, x minus 3. And you know, once we have fractions, we're adding or subtracting fractions. We find the LCM. The LCM will be 1 of each. So I have 2x plus 3, so I'm taking one of those. And I have 1x minus 3, so that will certainly be a part of the LCM. So I'm taking one of each. So let me divide x plus 3 into my LCM. My 2x plus 3's will divide into each other to give me 1. I'm left with x minus 3. X minus 3 by 1 gives me x minus 3. Bring down my addition sign. Let me divide x plus 3, x minus 3 into my LCM. That gives me 1. 1 by 3 is 3. And in simplifying that, I know negative 3 plus 3 is 0, which will leave me with x. And x plus 3, x minus 3, when you expand that, you're going to get x squared minus 9. So the answer there it is E. So very common questions, we want to make sure we can recognize. And if we see questions similar to such, we know how to work them out also. Yeah? So if you see this automatically, you know what to do. So let's move to the next. Given f of x is equal to ax squared plus bx plus c, it can be expressed in the form what? So this here is completion of squares. So this is why it's important for us to know the formula. So we know that h is b over 2a, yeah, and k will be 4ac minus b squared all over 4a. Yeah? So when we convert it into the form, we know a is the number in front of x squared, x plus h will be b over 2a, and plus k will be 4ac minus b squared all over 4a. Alright? So what corresponds to what we have there? Don't forget to all squared. So that will be a into x plus b over 2a all squared, and it's going to be 4ac minus b squared over 4a. So we're looking at d. So that answer there is d. So making sure we're clear on how to treat with these questions. So let's move on to the next. So this is a quadratic inequality. So again, when you look at the second slide, I highlighted sometimes the order in which the topics, questions in relation to topics are stated in the exam. So you know you'll have everything in relation to quadratics, you know, of course, remainder factor theorem, quadratic equations, quadratic inequations. Alright, so let's make sure we understand how to solve our quadratic inequality. So to solve the quadratic inequality, we have an inequality symbol. This is a quadratic expression. Of course, quadratic expression, inequality symbol 0 makes it a quadratic inequality. So we let x squared minus 7x plus 10 equal to 0. We're solving a quadratic equation first to help us to find the roots. So in solving this quadratic equation, we're going to factorize this expression. So we're taking 1 in front of x squared. I'm going to multiply 1 by 10, which gives us 10. And we want two factors of 10. When multiplied, will give 10, but when added or subtracted, can help us to get that middle term, negative 7x. So the two factors of 10 we can use are negative 5 by negative 2 will give us positive 10, but negative 5 attach x, negative 2 attach x gives us the middle term, negative 7x. So I'm going to rewrite my quadratic expression as x squared minus 5x minus 2x plus 10 is equal to 0. I'm going to factorize this expression, so I pair off what is common to my first pair, clearly x. I divide x into x squared to give me x. I divide x into negative 5x to give me negative 5. I'm going to factorize my second pair, the sign controlling the first term of the second pair, bring it automatically. And if I look, 2 is common, so negative 2 becomes my highest common factor. When I divide negative 2 into negative 2x, I get x. Negative 2 into plus 10, I get negative 5 is equal to 0. So I have the same expression in my bracket, so I know I'm on the right track. So I further factorize to get x minus 5x minus 2 is equal to 0. And I'm going to say either x minus 5 is equal to 0, x is 5, or x minus 2 is equal to 0, x is 2. Those will be my roots. But then to get my range of values as the option states, I have to now use my sketch to help me to find my range. So because the quadratic expression, the number in front of x squared is positive, I know when I sketch my curve, it's going to be one that's concave up. And the curve cuts the x-axis at my roots, which are 2 and 5. And to determine where the range of values, where they lie, the range of values that satisfy this inequality, where they lie, I look at the inequality symbol to help me. The inequality symbol is a less than. Less than means we're looking at the region below the x-axis. So below the x-axis, we're focusing on this region of the curve. I like to call it the belly of the curve. So therefore, my range of values of x will be greater than 2, and I'm using the word and because it falls within that region, and x will be less than 5. So x is greater than 2 and x is less than 5. But what we're going to do anytime it falls within the belly of the curve, this is something that we must know. We can collate or bring the inequalities together. So let's bring it together. This is what? I leave x less than 5 as is. What's on the right there? I leave it as is. But x greater than 2 is the same as if x is greater than 2, it's the same as saying 2 is less than x. So if x is greater than 2, 2 is less than x. So the inequality I'm looking at for this question, the answer will be B. So 2 is less than x, x is less than 5. Alright? So your quadratic inequalities. Right, so another very common question we see in the exam, rational inequalities. So also an inequality involving your understanding of quadratics and how we know how we're going to treat with a quadratic inequality. So I'm erasing all this. So 3x minus 2 all over 2x plus 1 is less than or equal to 0. It's called a rational inequality. So for us to solve that rational inequality, what we need to do is to remove it from the rational. A rational is a fraction. So let's remove it from the rational first by multiplying both sides of the inequality by the denominator squared. X 2x plus 1 squared. And when I do to one side, I must do to the other, right? So I multiply both sides by the square of the denominator. So look at what's going to happen here. So 2x plus 1 into 2x plus 1 squared gives me 2x plus 1. And I can multiply 2x plus 1 by 3x minus 2. So I can write this as 2x plus 1, 3x minus 2. So no more fractions here. It's less than or equal to 0 by 2x plus 1 squared is 0. So this here is a quadratic inequality. If I expand this, I'm going to get a quadratic expression. I have my inequality symbol 0, which makes it a quadratic inequality. So to solve this quadratic inequality, I need to get my roots, just like what I did with the question before. So I'm going to let 2x plus 1, 3x minus 2 equal to 0. And I'm going to say either 2x plus 1 is equal to 0, 2x is negative 1, and I divide both sides by 2. X is negative a half. Or 3x minus 2 is equal to 0. 3x will be equal to 2, positive 2. And I divide both sides by 3. X is equal to 2/3. So those are my roots. So what I'm going to do always with quadratic inequalities, you will use a sketch that will define your range of values. So if I expand these two binomials, you'll see what the number in front of x squared is positive, which will indicate that your curve, when you're sketching, will be concave up. The roots are negative a half, which is small on the number line, so that will be to the left, and 2/3, which is large on the number line, will be to the right. And where will my range of values align? Because it's a less than or equal to, it means I'm looking at the region below the x-axis. So below the x-axis will be this region here. And this region will be where my range of values align that satisfy that rational inequality. So what are the range of values? Now, I'm going to say here x is greater than, now I'm not going to use equal to minus a half, because if it's minus a half, we're using minus a half. If you were to substitute minus a half into that rational, you're going to get here 2 by minus a half is negative 1. Negative 1 plus 1 is 0. And once the denominator is 0 in a fraction, it means it's undefined, it doesn't exist, it can't work out. So minus a half certainly will not satisfy the inequality. If you substitute minus a half as I just did, you'll see where it will not satisfy the inequality. So we cannot include negative a half. So we have to say x is greater than negative a half, not greater than or equal to. We can't include negative a half because we, as I just showed you, negative a half will make that undefined. So it cannot be included. So x is greater than negative a half, and I use and because it falls within the belly of the curve. I call it the belly of the curve. X is less than or equal to 2/3. So when it falls within the belly of the curve, what we can do is to correlate, bring them together. So to bring them together, I leave my x less than or equal to 2/3 as is. But if x is greater than negative a half, it means negative a half is less than x. X is greater than negative a half, negative a half is less than x. So this is what we're looking at as our answer, which is C. Alright, so make sure we're familiar with these questions. If this comes in the exam tomorrow, all you have to do is shade, well, you look at your answers carefully, and if it's C, you shade, you circle or shade C. If not, make sure you know how to solve such a question, alright? So let's look at the next. Right, if f of x is equal to negative 2/9x cubed, and for that domain negative 3 less than or equal to x, less than or equal to 3. So which means we're looking at numbers from negative 3 to 3, domain which are your x values. Then, what will be the range? What is f of x? What is the range? We know the domain runs from negative 3 to 3 along the x-axis. So what is the range which is along the y-axis from the lowest to the highest value? So just assuming, let's assume that this is our curve negative 2/9x cubed. Let's assume it. X cubed is always a curve that shapes like that. So we're running from negative 3 to 3. That's along your domain. So what is the range? What is the f of x-axis or the y-axis? The range. So we want the lowest to highest value along the y-axis. So when it's negative 3, let's see. When it's negative 3, when x is negative 3, what is f of x? What is the corresponding y value? F of x will be negative 2/9 times negative 3 cubed. Negative 2/9 times negative 3 cubed will be negative 27. And negative 2/9 by negative 27 will give us, that will give us positive 6. So when x is negative 3, so let me do it something like this. So when x is negative 3, the corresponding y coordinate is 6. Alright, so when x is negative 3, the highest value on the y-axis is 6 when x is negative 3. Now when x is positive 3, so when x is equal to 3, what is f of x? F of x will be negative 2/9, 3 in brackets cube. That's negative 2/9 times 27. 9 into 27 is 3. 3 by negative 2 is negative 6. So when x is 3, we assume 3 is here, then the corresponding y will be what? That will be 6. So we know that the lowest value along the y-axis is 6. And negative 6, sorry. And the highest value is what? Positive 6. So your range can be written as negative 6 is less than or equal to f of x, which is less than or equal to 6. Meaning you're running from negative 6, the lowest value, to 6, the highest value. Whose answer there is, whose answer is C. Okay? So making sure we're clear, we see this question, how to treat with it. So let's look at the next. So we're looking at some questions now on indices, surds, and logarithms. So before we looked at remainder factor term, quadratic equations, and quadratic inequalities. So let's look at some indices, surds, and logs, right? So you can see this question very common. 2 to the power of negative 1 all over a to the power of a third. So that simplifies 2. So what we can do here, 8 is the same as, this is 2 to the power of negative 1. 8 can be expressed to a base of 2. 8 is 2 raised to the power of 3, all to the power of a third. And this is the same as 2 to the power of negative 1. We multiply a third by 3, which is 1. So we have 2 in our denominator. And what we can do here now is simply apply our law of division of indices. So once you have the same base, we can maintain the base 2, and the powers we can subtract. So a power of 1 is understood here. So this is negative 1 subtract 1. So this becomes 2 to the power of negative 2. And when you have a negative index of power, you can convert that back from a negative index of power to a positive index of power. So this is the same as 1 all over 2 to the power of 2. If I have to move from a negative index to a positive, I'll simply put 1 all over, maintain the base 2, but negative 2 becomes positive 2, which is also a quarter. Alright, so the answer for this question, it is going to be C. Okay, let's move on to the next. Right, so some surds and expansion. So you can see this question as well. So common, 8 plus the square root of 5 times 2 subtract the square root of 5. So we want to expand that. So normal expansion of binomials. So I'm going to multiply 8 by 2, which is 16. I'm going to multiply 8 by negative the square root of 5, which is negative 8 the square root of 5. I'm going to multiply positive the square root of 5 by 2. So that becomes positive 2 the square root of 5. And I'm going to multiply the square root of 5 by negative the square root of 5, which is the plus by a minus, is a minus. The square root of 5 by the square root of 5 is the same as the square root of 25. Right? And this will simplify to become 16. These two terms are like terms. Well, let me rewrite it first. And we know the square root of 25 is 5, right? So of course these two are like terms or like surds, so this can be simplified. Of course these two constants are like terms. So you know 16 subtract 5 is 11, and negative 8 the square root of 5 plus 2 the square root of 5 is the same as negative 6 the square root of 5. Yeah? Whose answer there will be A. 11 minus 6 the square root of 5. Okay, so let's move on to the next. So, surds. We see a question on surds and how to treat with it, right? So, surds again. 1 plus the square root of 3 over the square root of 3 subtract 1. This can be simplified to be equal to what? So, we have 1 plus the square root of 3, square root of 3 subtract 1. Again, surds. We never work with a surd in the denominator of a fraction, so you have to remove it. So to remove it, what you're going to do is carry out what you call rationalization. So you're going to rationalize. which means you're going to multiply this fraction by another fraction whose numerator and denominator is the conjugate of the denominator of this fraction. What's the conjugate of this denominator? It's simply changing the sign, so it's the square root of 3 plus 1 over the square root of 3 plus 1. So the fraction you're going to multiply this first fraction by, so this second fraction, must be the conjugate of the denominator of the first fraction. Alright? So let us multiply. This is 1 plus the square root of 3 by the square root of 3 plus 1 over the square root of 3 subtract 1 by the square root of 3 plus 1. So let's expand. So I'm going to expand 1 by the square root of 3 to square root of 3. 1 by 1 is plus 1. The square root of 3 by the square root of 3 to square root of 9. Which is shrinks, alright, 3 one time. Let me write the square root of 9. Let me show the steps. And the square root of 3 by plus 1 is a plus the square root of 3. Over, let me expand my denominator. The square root of 3 by the square root of 3 is the square root of 9. The square root of 3 by plus 1 is plus the square root of 3. Negative 1 by the square root of 3 is negative the square root of 3. And negative 1 by positive 1 is negative 1. So what we're going to get here, this becomes the square root of 3 plus 1 plus the square root of 9 is 3 plus the square root of 3 over the square root of 9 is 3 plus the square root of 3 minus the square root of 3 subtract 1. So let's simplify. The square root of 3 and the square root of 3, those two are like surds. So that becomes 2 the square root of 3. 1 plus 3 is 4. So 2 the square root of 3 plus 4 over 3 subtract 1, those are like terms. 3 subtract 1 is 2. And the square root of 3 minus the square root of 3 is 0. So you have 2 in your denominator. But of course, that is not in any of the options we have. So we need to, simplify that further. So to simplify that, what can we do? We can factorize the numerator. In my numerator, I can factorize this numerator. I can take out 2 as a common factor. When I divide 2 into 2 the square root of 3, I'm going to get the square root of 3. When I divide 2 into plus 4, I get plus 2 over 2. So of course I factorize the numerator now. And what can happen here now? What I can comfortably do now is to divide 2 into 2 to give me 1, which will leave me with the square root of 3 plus 2, whose answer there is D. Alright, so you see, and this is very common, very, very common question. So make sure you know how to treat with such. Sometimes they may put 5, the square root of 5 over the square root of 5. Sometimes they change it up. So please make sure you know how to work it out. Okay? Alright, let's look at the next. Right, so indices, and again, solving equations in index form. This is an equation in index form and we have to find x. So we have 3 times 27 to the power of 2x is equal to 9 to the power of x. So this is an equation, but an equation in what? In index form. So how are we going to solve that? What we need to do is to ensure all quantities are to the same base. So I'm going to, this is 3 times 27, I can convert to a base of 3. 27 is the same as 3 cubed, all to the power of 2x. 9 is the same as 3 squared, all to the power of x. So, on the left side, this becomes 3 times 3 to the power. I can apply my law of power to a power and multiplying 3 by 2x, which is 6x. And I can also apply power to a power on the right. This is 3 to the power of x by 2 is 2x. Now, when we are solving equations in index form, we want single terms on either side of the equal sign of the same base, meaning you want one term on the left to a base of 3, one term on the right to a base of 3. You already have one term on the right to a base of 3, so you want one term on the left to a base of 3. So how is that going to happen? I am going to simply apply my law of multiplication of indices. This 3 has a power of 1. I'm multiplying at the same base, so I maintain the base 3. This is your law of multiplication of indices, and you add the powers. So once I have one term on the left, one term on the right of the same base, what I can comfortably do now is simply say for an equal base, we equate the powers. So you're going to put the two powers equal to each other. So it's 1 plus 6x is equal to 2x. And let me solve that equation now. This is 6x, positive 2x comes across to the left as negative 2x. Positive 1 goes across to the right as negative 1. 6x minus 2x will be 4x is equal to negative 1. And I can now divide both sides by 4. X is equal to negative a quarter. So the answer there is E. Okay, let's move on to another. So making sure that we clear how to treat with these questions. Alright, don't forget to like, share, and subscribe to the channel. Alright? Don't forget that. Okay, so let's look at this one. Another very common question. We have the root of 3 times 27 to the power of m, and the order of that root it is pi. So they have pi as the order of the root. So how are we going to treat with this? So again, applying the laws of indices. This year I'm going to convert 27 into 3 to the power of 3, all to the power of m. Of course, my order is pi. And this becomes, I'll call it the pi root, we call it the pi root. And this is 3 times 3 to the power of 3 by m will be 3m. And now let me simplify further what I have under my pi root symbol. Yeah? So this will be the pi root, a power of 1 is understood here, and I'm applying my law of multiplication of indices. So once I have the same base, I maintain the base 3. And the powers I must add, 1 plus 3m. Now anytime you have the root symbol, the root symbol can be converted into a fraction. So for example, if you have the cube root of 8, just an example, 8 has a power of 1 which is understood. So you can convert this from the root symbol to a power that's a fraction. Maintaining 8 the base, 1 which is the power of 8 becomes the numerator of the fraction index, and 3 which is the order of the root becomes the denominator of the fraction index. So we are going to apply the same concept here. This will be 3 the base stays, 1 plus 3m becomes the numerator. Well, they have 3m plus 1. 1 plus 3m and 3m plus 1 is the same. It will be the numerator of the fraction index, and pi, the order of the root, becomes the denominator of the fraction index. Whose answer there is C. So common questions, you see that you know what to do automatically. Alright? So let's move on. Right, so logarithms. So we have here, given that, another very common question, log of x to the base p is equal to 6, and log of y to the base p is equal to 4. They want us to find the log of x over y to the base p. So what we're going to do here is apply our quotient law to this. I hope you all remember what's the quotient law. When you're dividing, what you're going to do is the expansion of that will be subtraction. So this will be log of x to base p subtract log of y to base p. So that is the quotient law. You call this the quotient law. And therefore, what's going to happen? Because the log of x to base p is 6, we replace that with 6. Log of y to base p is 4, replace that with 4. 6 subtract 4 will be 2, whose answer there is D. Alright? So let's move on to the next. Right, so this is another common one. The value of 2 to the power of z, where z is equal to 5 plus a log 3 to base 2 is. What is that answer? So they gave us this equation here. Z is equal to 5 plus log 3 to base 2. Good? So when solving equations in logarithmic form, what is important? It's important to get all terms in the same base. All terms in the same base. So you can express z to a base of 2. So this is a base of 2. Let's express z and 5 to a base of 2. Z expressed to a base of 2 is the same as z log 2 to base 2, because a log 2 to base 2, which is a rule or law of indices, is the same as 1. So this is 1 by z, which is a z. So this is the same z. 5 is the same as 5 log 2 to base 2. Again, log 2 to base 2 is 1, 1 by 5 is 5. But of course, you know, all we express into a base of 2. Yeah? Plus a log of 3 to base 2. And now that we have done so, we can apply what we call a power law. Power law is where I'm going to take this z in front of my log notation, and that z now becomes the power of 2. And you call this the argument. You call all those, you call them arguments. So therefore this becomes a log of 2 to the power of z. This z now becomes the power of 2. Your power laws, machinery laws, to base 2 is equal to, this 5 now becomes the power of 2. Log 2 to the power of 5 to base 2. Plus a log 3 to base 2. So this becomes log 2 to the power of z to base 2 is equal to 2 to the power of 5 is the same as 32. So this is a log 32 to base 2 plus a log 3 to base 2. And what's going to happen here? We are going to apply now to the right the product law, because the objective is to get one log function or one log term on the left of the equal sign to base 2 and one log term on the right of the equal sign to base 2. We already have one log term on the left to base 2, so let's get one log term on the right to base 2. So to do so, I'm going to apply what we call a product law. So this will be log, I'm multiplying 32 by 3. 32 by 3 will give me 96 to base 2. So now that I have one log term to base 2 on the left, one log term to base 2 on the right, all I'm going to do now is place the two arguments equal to each other. I'm going to equate the arguments. Drop log 2 and just equate the arguments. This will be 2 to the power of z is equal to 96. So when they ask us what is the value of 2 to the power of z, the value of 2 to the power of z, it is c 96. Alright? So make sure we understand that question. Okay, so let's move on to another. So looking at common questions we can see in the exam tomorrow. So let's look at this one here. Given log of x to the power of 3 to the base 2 is equal to 6. What is the value of x? Good? So to find the value of x, what are we going to do? We can do the same thing as what we did previously. This is an equation in a logarithmic form, so you want to make sure each term is expressed to a base of 2. This is to a base of 2, this is not to a base of 2, so we can express it to a base of 2. This will be what? Log x cubed to base 2, and 6 can be written as 6 log 2 to base 2. So you see, so that is now to a base of 2. And what I can do here is apply what I call my power law. I'll take my 6 and represent 6 as a power of 2. So I write this as a log x cubed to base 2 is equal to log 2 to the power of 6 to base 2. 2 to the power of 6 is the same as 64. So this is a log x cubed to base 2 is equal to log 64 to base 2. I want to have single log terms on either side of the equal sign to the same base. All I'm going to do is equate the arguments. So I'm going to put those two to equal to each other. X cubed is equal to 64. And therefore to get x by itself, x will be the cube root of 64. So I must find the cube root of both sides. And the cube root of 64, it is 4. Whose answer there is B. Alright, so making sure we're clear on some of these things. Right, so let's look at now questions involving series and sequences, roots involving alpha and beta, coordinate geometry, and equation of a circle, alright? So, of course, this is another very common question. The sum of the first n terms of a series is given by that. The sum of the first 10 terms is. So, once we're given this notation, it means it's sum, right? R equal to 1, this is the lower limit, meaning you're starting at 1. N is the upper limit, right? So we have this, want to find the sum to n terms. And this 5 minus 3r, that represents the formula to determine what each term is equal to. So they want us to find the sum of the first 10 terms. So you can start with r equal to 1, so you substitute 1 inside here, 5 minus 3 times 1, plus, you substitute 2, move it to the second term, 5 minus 3 times 2 plus, you can move to the third term, 5 minus 3 times 3 plus, and you keep going. You can go all the way down to the 10th term and then add them up. Because the after symbol here represents the sum. So this is the same as 5 minus 3 is 2 plus 5 minus 6. 5 minus 6 is negative 1 plus 5 minus 9, that's negative 4, plus dot dot dot. So this is the same as 2, subtract 1, subtract 4, plus dot dot dot. Now we want to find sum to 10 terms. Now like I said, you can simply use your formula and go all the way down to the 10th term and you add up all your terms to get the sum to 10 terms. But what you can do when you set it up as such, you can identify the type of series. If you look, this is 2, subtract 1, subtract 4. Now, this here, if I subtract 3 from 2, I get negative 1. If I subtract 3 from negative 1, I get negative 4. Which will tell me that this series here is an arithmetic series, it's an AP. So I know that my first term is 2, and my common difference D is negative 3. Alright? And therefore, what I can do now is find the sum to 10 terms. There's another approach you can use, right? So I can use my formula to find the sum to 10 terms, which is S is equal to N over 2 into 2A plus N minus 1D. I can use this to find the sum to 10 terms. So this will be N, which of course will be the number of terms, 10 terms. I know N in this case will be 10. This will be 10 all over 2. 2 times A, which is 2, plus 10 minus 1, which is 9. And D, of course, is negative 3. I'm multiplying n minus 1 by D. So you should put that minus 3 in brackets. This will be 2 to 10 is 5. This is 2 by 2 is 4. 10 minus 1 is 9. 9 by negative 3 is negative 27. So I'm going to get here 5. 4 minus 27 will give me negative 23. And when I multiply 5 by negative 23, I'm supposed to get negative 115, whose answer there is C. So this is me finding the sum to 10 terms. Sum to 10 terms. Okay? So using this approach that way. So let's move on to the next. So we have here, right, so again, another question, those two are questions you can't see in the exam. You have here, find the sum, summation symbol sum, 3, this is k equal to 1, you have 1 over k. K is the lower limit, meaning you're starting at 1, 3 is the upper limit, which means you want to find the sum to 3 terms. And 1 over k is the formula to determine what each term will be equal to. So this will be simply, and this means sum. So this is replacing k with 1, 1 over 1, plus 1 over 2, plus 1 over 3. That's basically what that is. And let's add that to get our answer. So this will be what? We have fractions. The LCM of 1, 2, and 3 is what? 6. So 1 into 6 is 6. 6 by 1 is 6, plus 2 into 6 is 3. 3 by 1 is 3, plus 3 into 6 is 2. 2 by 1 is 2. So you're going to get 6 plus 3 is 9. 9 plus 2 is 11 all over 6. Whose answer there is D. Okay? So let's move on to the next. Right. So what's the common ratio of the geometric sequence? So again, looking at sequences, another common question. You have 8, 12, 18, dot, dot, dot. It states here that this is a geometric sequence, a GP. And if we need to determine what is the common ratio, which is R in your geometric sequence, note this is your first term. This is your second term. So for the geometric sequence, remember the general term for GP is T is equal to AR to the n minus 1. Don't forget that formula. So the first term we can write simply as A. So you know A is 8. The second term, just replace n with 2. So if I replace n with 2, it becomes AR. Right? So that will be R to the power of 1. So it becomes AR is equal to 12. And to find the common ratio, when it comes to GPs, so you label both equations, you always divide the current equation or the current term by the previous. So the current is your second by the previous, which is your first. So you're going to divide, you're going to put AR all over A and 12 all over 8. Always divide the current by the previous. So therefore, your two A's will divide into each other to give you 1. And R, which is the common ratio, which is what you want to find, is equal to 12 over 8. And we can simplify that. 4 into 12, 3. 4 into 8, 2. So the common ratio there is 3 over 2, which is C. So now we can find the common ratio. Alright, let's look at another. Right, so this is another common one. the sum of odd integers between 10 and 50 is. So sum of odd integers between 10 and 50. So our odd integers, of course, you know, integers can be positive or negative numbers. We're focusing on positive integers here. So if it's odd, we're looking at from 11, 13, 15, all the way down to the last term, which is before 50, 49, which is odd as well. So we want to determine what is the sum of odd integers. So first thing we need to recognize, this here is a sequence, right? Sequence of numbers, odd numbers. And it is important for us to recognize the type of sequence. This sequence here is an arithmetic sequence because we have a first term A, which is 11, and we move from each term to the next by adding 2, right? So keep adding 2. So therefore you know that this here will have a common difference of 2. Yeah? So already we know that it's an arithmetic sequence. And if we have to find the sum to n terms, we don't know how many terms between, how many odd integers occur between 10 and 50. We don't know what that is, but we can find it. When we determine the number of n terms, number of terms, odd integers I should say, between 10 and 50, when we determine that, we can also find the sum, right, to those number of odd integers between 10 and 50. So, it being an arithmetic sequence, we can use the formula here. So, sum to n terms, and we'll find n shortly, so we know what n is, can be formed by using the formula s is equal to n over 2 into 2a plus n minus 1d. So we're going to use that formula to help us to find the sum to n terms. So how are we going to determine how many terms, how many odd integers occur between 10 and 50? This is what we do. Now 49 is the last term of the sequence. That's a number, the last odd number between 10 and 50. So because we know the last term, we can simply use this formula to help us to find n. So we know the formula is t is equal to a plus n minus 1d. That's the general, the formula used to help you to find any, the value of any term of that sequence. We call it the general term. So t here will be 49, which is the last term because you have that value. A will be your first term, which is 11, plus n minus 1. D, the common difference is what? 2. So let me find n. That's an equation where I can find n, the number of odd integers between 10 and 50. Right? So this will be 49 is 11. Let me remove my brackets. This is plus 2 by n will give me 2n. 2 by negative 1 is negative 2. So I'm going to get 49 is equal to 11 minus 2, which is 9, plus 2n. Let me subtract 9 from both sides. 49, subtract 9, positive 9 comes across to the left as negative 9, is equal to 2n. 49 minus 9 is 40, is equal to 2n. And then I can divide both sides by 2 to the number of odd integers between 10 and 50 will be 20 of them. So now that I know the number of odd integers, let me now find the sum of odd integers between 10 and 50. So this will be n, which is 20, over 2 into 2 times a, which is 11, plus 20 minus 1, d, which is 2. So I'm going to get s is equal to 2 into 20 is 10, 2 by 11 is 22, plus 19 times 2, s is equal to 10 into 22 plus 19 by 2 will give me 38. S is equal to 10 into 38 plus 22 will give me 60. And 60 by 10 will be 600. So the sum of odd integers between 10 and 50 will be 600, whose answer there is B. Okay? So let's look at another So, again, common question, common. For the arithmetic progression, negative 12, negative 7, and so on, the nth term is given by what? What is the nth or last term? So we have negative 12, negative 7, negative 2, 3, 8. This is an arithmetic progression, or an arithmetic sequence of numbers. So if it's arithmetic, we know we have our first term A, which is negative 12. We know the common difference here. If I keep adding 5, good? I'm going to, of course, move from one term to the next, so my common difference is 5. And I want what is the nth term of the sequence. So I'm going to use my formula, t is equal to a plus n minus 1d, to identify what is the nth term, the answer in terms of n. So this will be a, which is negative 12, plus n minus 1d is 5. So it's negative 12 plus 5n minus 5. So I'm going to get negative 12 subtract 5 is negative 17. 5n minus 17. And therefore my answer there will be D. Alright? So if you see that question tomorrow, you know what to do. Okay? Alright, so let's move on to the next. So the first 4 terms of a convergent geometric progression, GP, is given by what we have there. So we have 500, 200, we have 80, we have 32. Right? What is the sum to infinity of this GP? So the sum to infinity. So the sum to infinity, we know, is A over 1 minus R. That's a formula for your sum to infinity. Where we know R must be less than 1. The common ratio is less than 1. Sum to infinity is only applicable to a geometric progression. So, all we need to do, we know the first term already is 500. So we need to find R. And if you're not sure what is R, this is what you can use to help you to find R. You know your first term is 500, you have the second term, which is AR, is 200. So we're going to divide my current by my previous. So the current here will be AR divided by the previous, which is A, and this is 200 divided by 500. So when those two A's divided each other to give 1, I'm left with the common ratio, which is 2/5. So I know the common ratio is 2/5. And knowing what's the common ratio, I can now find the sum to infinity. Knowing my common ratio, my first term, let me get my sum to infinity. So the sum to infinity will be A, which is 500 over 1 minus 2/5. So this is 500. 1 is the same as 5 over 5 minus 2 over 5. That's 3 over 5. And that's 500 multiplied by 5 over 3. So 500 divided by 3 because it's the same as 500. Change the division to a multiplication and invert to become 2500 over 3, whose answer there is D. Alright, so making sure we know how to find the answer to these questions. Alright, let's move on to the next. Right, so given that A and B are the roots of the equation, what is the value of A plus B all squared? Now, of course, sometimes they may use alpha and beta, or they can use A and use letters of the alphabet A and B. So you have this quadratic equation, x squared plus 3x plus 4 is equal to 0. Yeah? And we know A is equal to the number in front of x squared, which is 1. B is the number in front of x, which is 3. C is a constant, which is 4. And you know when it comes to roots involving alpha and beta, in this case they use A and B instead of alpha and beta. Then you know the sum of the roots A plus B is minus B over A, and the product of the roots AB is C over A. Alright? So what we can do, we can work out what is, because we have the sum of the roots all squared, right? So let's work out what is the sum of the roots. This will be subtract 3, which is B, is 1, so we have negative 3. And all we need is the sum of the roots. So therefore, A plus B all squared, the sum of the roots will be negative 3 in bracket squared. Negative 3 by negative 3, which is positive 9, whose answer there is C. Alright? So roots involving alpha and beta. So let's make sure we see a question like this in how to treat it. And we like to bring the roots involving alpha and beta. Okay, so let's move on. Again, question involving roots involving alpha and beta, but creating the quadratic equation based on the roots alpha and beta, right? So it says here the quadratic equation is such that the sum of its roots is negative 2/3 and the product of its roots is 3/4. What is the quadratic equation? So the quadratic equation when it comes to roots involving alpha and beta is this: x squared subtract the sum of roots times x plus the product of roots is equal to 0. So that's the general quadratic equation when it comes to roots involving alpha and beta. So we know this will be x squared. Subtract, they told us what's the sum of the roots, that's a negative 2/3 in brackets x plus the product of the roots is 3/4 is equal to 0. So when we simplify that, we're going to get what? X squared. A minus by a minus is a plus. 2/3 x plus 3/4 is equal to 0. And then what we can do here is because this is not in any of the options, but we can remove it from the fraction by finding the LCM of 1, 3, 4, and 1, which is 12. So I'm going to multiply each fraction by 12. So 12 by x squared gives me 12x squared. 12 by 2/3 x, 3 to 12, 4, 4 by 2x is 8x. 12 by 3/4, 3 to 4 to 12, 3 3s are 9, and 12 by 0 is 0. So we should have 12x squared plus 8x plus 9 is equal to 0, whose answer is E. So make sure we know that very important formula, alright? When it comes to roots involving alpha and beta. Alright, let's move on to the next. So, this here it is a bit of coordinate geometry. A line L passes through the point 6,5 and is perpendicular to a line whose equation is 3x plus 4y minus 7 equal to 0. What is the equation of L? So you have a line L passing through, let's assume that this is my line L, and it passes through the point whose coordinates are 6,5. And this line L is perpendicular. No, perpendicular simply means where one line meets another at right angles. That line L is perpendicular to a line whose equation is 3x plus 4y minus 7 is equal to 0. So they want us to determine what's the equation of this line L. So to find the equation of a line, we know we're going to use the formula y is equal to mx plus c, and we know we need to find the gradient m and the y-intercept c. So to find the gradient of this line L, because it is perpendicular to this line whose equation we have what we can do, we can find the gradient of this line by taking the equation. We're going to make y the subject in order for us to find the gradient of this line. Using the equation, we have to make sure we express the equation in this form. Y is equal to mx plus c. So let me make y the subject of the formula first. This is 4y. Positive 3x comes across to the right as negative 3x. Positive 7 negative 7, comes across to the right as positive 7. And then what I'm going to do is to divide both sides by 4 so I can make y the subject. When my two 4's divide into each other, y now stands alone. And my gradient here and my y-intercept can be found by separating my terms. I write this as negative 3 over 4x plus 7 over 4. So you must separate it first. So this is y is equal to negative 3/4 x. So negative 3x over 4 is the same as negative 3/4 x plus 7 over 4. So the gradient of this line is the number in front of x, negative 3/4. So the gradient of this line here is negative 3/4. I remember when two lines are perpendicular, if you know the gradient of one line, you can find the gradient of the other by using what you call the negative reciprocal, negative 1 over negative 3/4. So the gradient of this line here, L, the gradient will be negative 1 over negative 3/4 becomes positive 4 over 3. When you divide negative 1 by negative 3/4, you get 4 over 3. So knowing what's the gradient of this line, and knowing that this line passes through the point 6,5, I can now find the equation of this line, which is what I wanted to find, right? So let's find the equation. So the gradient of this line is 4 over 3. The point it passes through has coordinates 6,5, the only point it passes through. So this is x, this is y. I'm going to replace y with 5, m with 4 over 3, x with 6 in brackets plus c. So I'm going to get 5 is equal to 4 over 3 by 6. 3 to 3, 1, 3 to 6, 2, 2 by 4 is 8 plus c, and therefore to get 8 c by itself, I'm going to subtract 8 from both sides. So positive 8 comes across to the left as negative 8, and c is negative 3. So the equation of this line L now can be written as y is equal to 4 over 3x subtract 3. Yeah? But that option is not, this here is not in any of the options. So what I need to do is to remove this from the fraction. Yeah? So how am I going to remove this from its fraction? I'm going to remove this from its fraction by putting y over 1, 4 over 3, and negative 3 over 1. My LCM here is what? 3. So I'm multiplying 3 by y, 3 by 4 over 3x, and 3 by negative 3. So help me to remove the equation from its fraction. So 3 by y gives me 3y. 3 by 4 over 3x gives me 4x. And 3 by negative 3 is negative 9. Good? So what I want to do is to ensure all my terms are on one side and the other side I have 0. So this plus 3y, let me bring it over to the right. This becomes 0 is equal to 4x. Positive 3y will come across as negative 3y minus 9. So the equation we're looking at is 0 is equal to 4x minus 3y minus 9. That answer there is D. So that's the equation of that line L. Okay? So let's move on to the next. So we have next the line through the point Q, H2, and R, 4, 6. Is parallel to a line with equation 2x plus y minus 10 is equal to 0. Find the value of each. So what's the value of each? So this is a line which passes through the point Q, whose coordinates are H2, and R, whose coordinates are 4, 8. It is parallel to a line with equation, 2x plus y minus 10 is equal to 0. They want us to determine what is the value of each. So to find the value of each, how are we going to find each? We know when lines are parallel, their gradients are the same. So M1 is equal to M2, both gradients are the same. So if we have to find H, it requires us to create an equation. So how are we going to find the equation? Let's get the gradient of this line using, I have 2 points, so I can use my formula y2 minus y1 over x2 minus x1. And let me find the gradient of this line by making y the subject, and hence the number in front of m is my gradient, and then I'm going to put them equal to each other because they are both equal since they are parallel lines. So let's get the gradient of our Q. This is a QR. This is x1, y1, x2, y2. So my gradient m. So gradient of line QR will be m is equal to y2 subtract y1 over x2 subtract x1. y2 it is 8 subtract y1 it is 2 over x2 it is 4 subtract x1 which is h. And let me find the gradient of this line whose equation is 2x plus y minus 10 is equal to 0. So gradient of line 2x plus y minus 10 equal to 0 is. So let me make y the subject. So y is equal to positive 2x comes across to the right as negative 2x. Negative 10 comes across to the right as positive 10. So the gradient of this line here, m, is equal to negative 2. Alright? So I have the gradients of both lines. I have the gradient of this line, which is 8 minus 2, I can write it as 6 all over 4 minus h. And I have the gradient of this line here, m, which is negative 2. And because they are parallel, then both gradients are the same. So I can place the gradients equal. I can put m1 equal to m2. m1 is 6 all over 4 minus h. And we see why is 6. This is m is equal to 6 over 4 minus h. And that is equal to m2, which is negative 2. So I have an equation which will now help me to find h. So what am I going to do here? I'm going to put negative 2 over 1. I'm going to cross multiply. This is negative 2 times 4 minus h in brackets. 6 by 1 is 6. So negative 2 by 4 is negative 8. Negative 2 by negative h is plus 2h is equal to 6. And therefore 2h is equal to 6 plus 8. 2h is equal to 14, and therefore I can divide both sides by 2. H is 7. So So the value of h, it is 7. Whose answer is D. Okay? So making sure we're clear on these equations. So let's look at these questions and of course how to solve those equations also. So let's move on to the next. So common questions we can see in the exam, and we want to make sure that we're familiar with how to work them out. Some students just depend on what they see the question here, they circle the right answer, but let's make sure we know how to work them out, okay? Alright, so we're looking at the equation of a circle here. A circle C has center 3, -2 and radius 4. What is the equation of the circle? So the center C has coordinates 3, -2 and the radius it is 4. So you know with a circle, you have a circle, you have the center, and that's a radius. Right? So they want us to find the equation of the circle. So we have to know, and we want the equation, if you look at the options in the general form, that's the expanded form. So we know the equation of the circle in the expanded form, provided h and k are both positive, is going to be x squared plus y squared minus 2hx minus 2ky plus c is equal to 0. Very important formula you must know, right? And c in this formula is h squared plus k squared minus r squared. So all we're going to do is find c. We already know what is h and k, and we substitute into our general formula, and let's see which one of those options is going to apply to. So let's work out c first. So c will be, I'm replacing h with 3 in bracket squared plus, I'm replacing k with -2 in bracket squared, subtract, I'm replacing r with 4 in bracket squared. So c is 9 plus -2 squared will be 4, subtract 16, 9 plus 4 is 13, 13 subtract 16 is -3. Good? So now that I know what is c, let me substitute for h and k into my equation, yeah? My general equation. So this will be x squared plus y squared, subtract 2, I'm replacing h here with 3, in brackets x, subtract 2, I'm replacing k with -2 in brackets y, and I'm replacing c with -3 is equal to 0. So when we simplify that, what are we going to get? This becomes x squared plus y squared, -2 by 3 is -6x, -2 by -2y is positive 4y, minus 3 is equal to 0. And that is the equation of my circle with center 3, -2, radius 4, whose answer is C. Making sure we know how to work it out, alright? Let's make sure we're clear. Let's make sure we're clear on this. Right? Because we don't know CX, you can make minor changes. Even though they repeat a lot of these questions, these are common questions. Let's make sure we know how to work them out. Alright, so let's move on to the next. So again, equation of a circle. Common questions we can see. So they want us to, what are the coordinates of the center of a circle given that equation? The equation of the circle is x subtract 1 squared plus y plus 3 squared is equal to 36. They want the coordinates of the center, which is represented normally by h and k. So this equation of the circle is the standard form, which is derived from Pythagoras theorem, So the standard form, the equation is x minus h in bracket squared, provided your center of the circle is positive h and k, right? Then you'll use this formula for the equation of the circle derived by Pythagoras. Sometimes you see where the sign between x and h is positive, right? So if you consider the center to be positive h, positive k, you're using x minus h in brackets whole squared plus y minus k in brackets whole squared is equal to r squared. So we want the equation given, which is that equation there, to directly correspond to that of the standard equation, this here. So for it to directly correspond, this is what we're going to do. This is x subtract 1 in bracket squared as in x minus h, already know h is 1, plus y subtract k, this is y plus 3. So to get it in the form y subtract k, I'm going to rewrite y plus 3 as y subtract negative 3 in bracket squared is equal to r squared. So h in this case is automatically 1 and k is automatically, we have y subtract k, which is negative 3. So you know h and k, the coordinates of the center will be 1, negative 3, whose answer there is D. Alright, so make sure you know how to figure it out, yeah? Alright, so let's move on to now some vectors and trigonometry. So make sure, if we see these vector questions, these trigonometry questions, we know we can easily circle them once we see the same question. If not, we know how to work them out. Okay, so let's look at it. And don't forget to make sure you like, share, and subscribe to Moyo Math. Okay, so let's look at the vectors. So easy, very common. Two vectors are equal if they have the same magnitude and the same direction. They must move in the same direction and must have the same magnitude, whose answer is B. Straightforward. Alright? So let's move on to the next. So very, very straightforward question. Right, this is another common question with vectors. Right, so let's hope that we see all these questions tomorrow. We'll be smiling. A vector A is given as 5y plus 12g. That's a vector A. The unit vector parallel to A is what? Now, what is a unit vector? Now, a unit vector is a vector which is just basically a fraction. This is the given vector A. The unit vector, which I write as A hat, is just a fraction. It's a little piece, little fraction of the given vector. Alright, moving in the same direction. So therefore, the unit vector is always formed by using a formula. That formula, it is a fraction. The fraction is 1 all over the modulus of A. And there's a formula to find modulus times the vector A. That's the formula to find the unit vector. So it's 1 all over the modulus of A is the square root of x squared plus y squared times the vector A, which we have as 5y plus 12g. So let's find x and x squared and y squared. We know x in this case will be your 5, y will be 12. But just keep in mind, this can also be rewritten as 5, 12. So this is x and that's y. So you can rewrite it as a column vector. So 5 is x and 12 is y, right? So this is 1 all over the square root of 5 in bracket squared plus 12 in bracket squared times the vector A, which is 5y plus 12g. So this becomes 1 all over the square root of 25 plus 144 times 5y plus 12g. This becomes 1 all over 25 plus 144. This is 1 all over the square root of 169 times 5y plus 12g. The square root of 169 is 13, so this is equal to 1 all over 13 times 5i plus 12g. Yeah? And we don't have to remove the brackets. Let's see if any of those options are yes, it's there, which is 5i plus 12g. Yeah? So the unit vector, let's make sure we know that. I'm sure you're going to see it something like this tomorrow. So make sure you know it. Alright, so let's look at the next. Right. Straightforward and another common vector question. Given that OA is negative 1725 and OB is 45, then what is vector AB? Straightforward vectors you see in mathematics as well. Straightforward. So you know that this is simply what? So vector OA, the magnitude is negative 1725. Vector OB, the magnitude is 45. And they wanted to find vector AB. You know vector AB using your equation based on the triangle law. Vector AB will be vector AO plus vector OB. Vector AO, this is vector OA, so vector AO means you move in the opposite direction and the signs will change. So vector AO will be positive 17, negative 25, plus vector OB 45. So when we work that out, vector addition here, 17 plus 4, negative 25 plus 5. 17 plus 4 will give us 21, negative 25 plus 5, negative 20. So 21, negative 20, whose answer there is D. Okay? So let's look at another vector question. Again, common questions, yeah? So, we have here the position vectors of A and B relative to an origin O are 2, 5, 3, negative 1 respectively. The acute angle AOB is, so of course we know to find an angle between two vectors. So of course the angle will be found by using your, what you call your dot product. Sometimes you see scalar product. So using a dot product, so you have your two position vectors, OA dot OB is equal to the modulus of OA dot, which means to multiply by the modulus of OB cos theta. Our aim is to find the angle theta. So vector OA is 2, 5 dot vector OB is 3, negative 1 is equal to the modulus of OA, which is the square root of 2 squared plus 5 squared dot the modulus of OB, which is 3 squared plus negative 1 squared cos theta. So let's work out what is OA by OB, which is what? 2 times 3 plus 5 by negative 1 is equal to the square root of 4 plus 25 dot the square root of 9 plus 1 cos theta. This will be 2 by 3, 6 plus 5 by negative 1 is negative 5 is equal to 4 plus 25. This is the square root of 29 dot 9 plus 1 is 10 cos theta. So a plus by a minus is a minus. 6 minus 5 is 1 is equal to the square root of 29 by the square root of 10. Applying your knowledge of multiplication of surds becomes the square root of 290. 29 by 10 is 290 cos theta. And therefore, to get theta by itself, we're going to remove the square root of 290 first by dividing both sides by the square root of 290. And to get theta by itself, I'm going to remove cos, which comes across to the left as cos inverse of 1 all over the square root of 290, and that is equal to theta, whose answer is A. So common questions, let's make sure we're clear on it. Alright, so let's look at some trigonometry now. So we have here some trigs. If sine theta is equal to pi over 13 and theta is obtuse, then what is tan theta? How are we going to find tan theta? Now, using our quadrant here. So sine theta is 5 over 13. Now they told us theta is obtuse, and obtuse angle is an angle that is more than 90 but less than 180. So we'll have here 0 degrees, 90 degrees, 180 degrees, 270 degrees, and we're back to 360. Right? Full revolution there. So if it's obtuse, it means it lies between 90 and 180. So we're focusing on the second quadrant. So our theta will lie in the second quadrant. See, that theta is obtuse. So we're looking at this here. We're going to create this right angle triangle in the second quadrant. This is my angle theta. Of course, if it's sine theta in that second quadrant, sine is opposite all over hypotenuse. The opposite side is the side opposite theta, which will be 5, and the hypotenuse will be 13. Which is opposite the right angle. The hypotenuse is always positive. So, to find this side here, which in turn will help us to find tan theta, I'm going to use Pythagoras theorem to find this side. So, using Pythagoras theorem, we know Pythagoras theorem is what? Pythagoras theorem, we always start with the hypotenuse squared, which is what? 13 in bracket squared is equal to the sum of the squares of the other two sides. I want to find that side x. So it's going to be 5 in bracket squared plus x squared. 13 squared will be 169. 5 squared is 25 plus x squared. This is 169. Positive 25 come across to the left. That's negative 25 is equal to x squared. 169 subtract 25 is 144 is equal to x squared, and therefore x is the square root of 144, which is 12. So I know that this side here will be 12. But we have to be very careful. Remember, this is on the what? Consider this to be your positive axis and your negative axis. So this here, of course, will be negative 12. So you can't write positive 12, right? Because it's on the negative side of the axis, x-axis. So therefore, if we have to determine, now that we know all three sides, tan theta is equal to what? Side opposite all over side adjacent. This is the side opposite here. Hypotenuse. Adjacent, tan is opposite all over adjacent, which is 5 all over negative 12, or negative plus divided by minus is a minus, negative 5 all over 12. Whose answer there is B? Alright, so make sure you understand that. Common questions. So let's move on to the next. So we have here the smallest positive angle in radians with the range, and right, another common question. 0 is less than or equal to theta, less than or equal to 2 pi. That satisfies the equation 2 cos theta minus 1 and cos theta minus 2 is equal to 0. We want what's the smallest positive angle. So, first to do so, see now we have two factors. We're going to take each factor, either 2 cos theta minus 1 is equal to 0. And let me get my values of theta that will satisfy the equation. This is an equation, a trig equation. So 2 cos theta is equal to 1. The good thing, already have the factors. They already gave us in terms of factors. So we place each factor equal to 0. Cos theta is equal to a half. Theta is equal to cos inverse of a half. And we know that cos inverse of a half is at 60 degrees. And 60 degrees, now what the answer in radians are, right? So you know 60 degrees is the same as pi over 3. And that's a principal value. So the secondary value when you're solving a trig equation, you must use the quadrant analysis test. So we have a positive principal value. We're looking at cos. Cos is positive in A and C. So to get the secondary value is going to be 360 minus theta, or 360 subtract theta, which is 60 degrees, which will give us 300 degrees. Alright? And 300 degrees in radians, that is what? That's 180 degrees is pi radians, 1 degree is pi over 180, 300 degrees is pi over 180 times 300. 0 go, 0 go. 6 into 35, 6 into 18, 3, right. So this is the same as 5 pi over 3 radians. Okay? So when we took the first factor, place it equal to 0, we got our values of theta that satisfies the equation. So let's take the or now. Or cos theta minus 2 is equal to 0. Cos theta is equal to 2. Theta is cos inverse of 2. Now cos inverse of 2, we go shift cos of 2 is undefined. So it's undefined. So that can't work out. So the values of theta we're focusing on are only these two. But whenever they ask us for the smallest positive angle. So the smallest positive angle here will be pi over 3. So the smallest positive angle will be A, which is pi over 3. That's the smallest positive angle. Okay? So let's look at the next. So trig equations, trig questions, get familiar, okay? Get familiar. Common questions that we can see. Alright, let's see next. Right, so again, another common question. You can see they may ask you to prove the identity. You have the trigonometrical expression given as sin x over 1 minus cos x plus sin x over 1 plus cos x. So you need to see this. What do you do? And what we are required to do? We are required to simplify that. That is identical to what? So we know to simplify this, we are going to first find the LCM. The LCM is 1 of each. 1 minus cos x, 1 plus cos x, 1 of each. So 1 minus cos x into my LCM. These two will divide into each other to give 1, which will leave me with 1 plus cos x, which I'm going to multiply by sin x. So I can write this as sin x into 1 plus cos x. Plus, let me divide the denominator into my LCM, which will give me 1 minus cos x. So I'm multiplying sin x by 1 minus cos x. So what I'm going to do now is to remove my brackets. So this will be sin x by 1 is sin x. Sin x by plus cos x is plus sin x. Cos x, let me remove my brackets here. Sin x by 1 is sin x. Sin x by negative cos x is negative sin x. Cos x all over my LCM, of course, what we can do, we can expand this also. So if we expand this, what are we going to get? 1 by 1 is 1. 1 by cos x is plus cos x. Negative cos x by 1 is negative cos x. Negative cos x by positive cos x is negative cos squared x. So what's going to happen here? In my numerator, my sin x cos x cancels with my negative sin x cos x. Those two will cancel out. That's 0. So I have sin x plus sin x is 2 sin x over cos x minus cos x is 0. So I'm left with 1 minus cos squared x. And we know 1 minus cos squared x, I hope we all know our trig identities, is the same as sine squared x. 2 sine x all over sine squared x. And I can now further simplify. I can say sine x into sine squared x is sine x. So I have 2 over sine x as my answer, which is C. So that's proven the identities there. Okay? So make sure we're aware and understand what the trick goes. Alright, let's look at the next. Right, so we have here another common question. This is another common question. So we have here, so they want us to find the exact value of sine 150 degrees over cos 150 degrees. Good? Now, sine of 150, that's a special angle. Sine of 150 is equal to, that's equal to a half, right? That's the same as sine of 30. Sine of 150 is a half. Because 150 is a special angle, right? And cos of 150 is equal to the square root of 3 over 2. Very important to know. So sine of 150 is a half, cos of 150 is the square root of 3 all over 2. Yeah? And therefore, when we simplify that, we're going to get a half multiplied by 2 over the square root of 3. And therefore, when these two cancel, I'm left with 1 over root 3, whose answer there is B. So these are special angles. 150 is a special angle. So make sure we know them. Alright? Okay, so let's move on to the next. So we have here, right, another common question. I'm sure you know, doing past papers would have seen this in almost every paper. The size of angle x measured in radians is. So of course, let's find x in degrees first. So x will be what? 180 subtract 34 degrees plus 110. 180 subtract 34 plus 110 will give us 144. And when we subtract 144 from 180, we're going to get what? We're going to get 36. Yeah? So let's convert 36 degrees into radians. So we know 180 degrees is always pi radians. 1 degree is pi over 180 degrees, and therefore 36 degrees is pi over 180 degrees times 36 degrees. Which will then simplify to what? I can say 9 into 36 is, I can divide 36 into 180 one time. That's what? That's 5. Yeah, 36 into 180 is 5. So you're going to get pi over 5 as your answer, which is E. Yeah? Yeah. His answer is E. Okay? So let's look at the next. So going through common questions, you can see. Right, another very common question, very common. Which of the following graphs represents y equal to sin x? A sine function is always sinusoidal. So it's defined between 1 and -1, and between the period, this is what? This is 0, 90, 180, 270, 360. So you're looking at this. Start at 0, turns at 90, cuts at 180, turns at 270, and end at 360. Yeah? So that there is sorry. 3/2, Yeah? Right, so therefore, this is what we're looking at here. So, our answer for this will be D. Alright? So, let's move on. So, if you see that question, will automatically is D, that sinusoidal shape. Alright, so let's move on to the next. Right, so another common question, very common. This one is very common. Sine alpha plus 45 degrees is equal to what? So sine alpha plus 45 degrees, what we have here are sine alpha plus 45 is a compound angle, and you have to know what is your compound angle expansion formula. So sine of alpha plus 45 degrees is same as sine of alpha. Well, let me write it like this first. Sine of A plus B is equal to sine A cos B plus cos A sine B. So we're applying that same formula to this. This is sine alpha cos 45 degrees plus cos alpha sine 45 degrees. And 45 degrees is a special angle. 45 degrees is the same as sine alpha times 1 all over the square root of 2. That's 45 degrees, cos of 45 degrees, which is a special angle in third form, plus cos alpha sine 45 is the same 1 all over the square root of 2. So therefore, what we're going to do here is to factorize. I have 1 over the square root of 2 common to both, which will leave me with sine alpha plus cos alpha, whose answer is E. Okay? Alright, so let's look at now, looking at, this should be differentiation and integration looking at now, right? So differentiation and integration. So getting into some differentiation and integration, which you know normally is the latter part of the exam paper. So let's differentiate this. We have differential of the square root of 7x squared plus 4. Good? So if we have to differentiate that, what we're going to do? That function there is a composite function. This is the same as to the power of a half. The square root can be expressed as a fraction. And if I have to differentiate that, if y is equal to that function, then you know when I'm differentiating, you must start with the differential coefficient dy over dx. And if you differentiate, this is a composite function. So it's a half by 1, which is understood in front of your bracket, 7x squared plus 4. 1 is understood here. A half by 1 is a half. I'm going to keep my 7x squared plus 4, and I subtract 1 from the power to give me negative a half. But remember, when you're differentiating a composite function, you have to implement what you call the chain rule. So I have to now multiply this by the differential of what I have inside the brackets. which comes from what we call, this is the chain rule we are applying here. So therefore this becomes dy over dx is a half into 7x squared plus 4 to the power of negative a half times the differential of what I have in brackets, the differential of 7x squared plus 4, the differential of 7x squared will give me 2 by 7 is 14, keep x, subtract 1 from the power, the differential of 4 is 0, so I have 14x. Let me multiply 14x by a half into 7x squared plus 4 to the power of negative a half. A half by 14x will give me 7x times 7x squared plus 4 to the power of negative a half. And if I have a negative index, I want to convert that into a positive index. So this is the same as dy over dx. It will be 7x times, let me convert this into a positive index, 1 all over 7x squared plus 4 to the power of positive a half now. Which is the same as saying dy over dx will be 7x by 1 is 7x, and 7x squared plus 4 to the power of a half can be written as the square root of 7x squared plus 4. Whose answer is B. So that is us differentiating that function known as a composite function. So make sure you know your function and how to differentiate that, right? Because they may bring the same question, they may change it up a bit, so make sure you know it. Alright, so let's see next. So, next, given that cos 2x, y is equal to cos 2x, then what is the differential of that? So y is equal to, another common question, y is equal to cos 2x. What's the differential of cos 2x? Again, when you differentiate a trig function, you also use the chain rule. So therefore, this will be dy over dx. The differential of cos 2x will be negative sine 2x, negative sine the angle, times, using the chain rule, the differential of the angle. So this is the chain rule we implementing here. So the differential of cos the angle is negative sine the angle times the differential of the angle. So therefore we're going to get dy over dx is negative sine 2x times the differential of 2x is 2, which will leave us with dy over dx is negative 2 sine 2x, whose answer there is C. Okay? So making sure we know how to differentiate. Alright, let's look at the next. So the gradient at x equal to pi over 6 on a curve, y equal to cos x is. So what's the gradient? Yeah? So we know if y is equal to cos x, so what's the gradient as a value? Good? So we have the function y equal to cos x. So let's get the gradient of that function. dy over dx, we know that again, differentiating a trig function, the differential of cos the angle is negative sine the angle times, using the chain rule, the differential of the angle, x. So dy over dx will be negative sine x times 1. Which will give you negative sine x. So many of you know that, right? You know the differential of cos x is minus sine x. But of course, the chain rule, implementing the chain rule to get that answer, right? So now that we know it, when x is pi over 6, so when x is pi over 6, dy over dx will be what? Negative sine of pi over 6. Yeah? Pi over 6 is the same as when pi is a part of a trig function, you consider pi in this case to be 180. That's 180 divided by 6, which is 30 degrees. So we're just saying negative sine 30 degrees. And sine of 30 is a special angle. Sine of 30 is a half. So you have to know your special angles, all your special angles. 30, 60, 45, right? 120, 150, all those are special angles. So sine of 30 is the same as a half. So this becomes maintain a negative sign. Sine of 30 is a half. So you have negative a half. Whose answer there is? So let's look at next. So given y is equal to 5 minus 2x in bracket raised to the power of 5, that's the power of 5, then what is dy over dx? Be sure you know how to differentiate all these functions, you can recognize it, alright? So if y is equal to 5 minus 2x all to the power of 5, what is dy over dx? So we're going to use that is the chain rule again. That is a composite function. So dy over dx will be, take 5 multiplied by 1, which is 5, keep 5 minus 2x, subtract 1 from the power, which is 4, using the chain rule, times the differential of what is in brackets. So dy over dx will be 5 into 5 minus 2x to the power of 4 times the differential of 5 is 0. The differential of negative 2x will be negative 2. And you can multiply negative 2 by 5 into 5 minus 2x to the power of 4, which will give you dy over dx. 5 by negative 2 is negative 10 into 5 minus 2x to the power of 4. Whose answer there is E. So let's look at the next, another common question. So looking at the more common questions we can see in the exam, right? At the point 7 for the curve, dy over dx is equal to 0, which automatically tells us that that point 7 is a stationary point once dy over dx is equal to 0. And the second derivative is negative 5. The point 74 is, what kind of point is that? So if it's a stationary or turning point, it could be maximum, it could be minimum. Good? So, anytime you know dy over dx is equal to 0, so it's a stationary point. And when the second derivative is less than 0, you see it's negative 5, that will always tell us that this one that is less than 0, it's a maximum point. So anytime the second derivative is less than 0, it is a maximum point. Whose answer there is D. Okay, let's look at another. Common questions, get familiar. So let's differentiate that function. Y is equal to 2x squared add 3 cos x. So what is that equal to? So dy over dx. Differential of 2x squared, 2 by 2 is 4, keep x, I subtract 1 from the power, and the differential of 3 cos x, the differential of cos the angle would be negative sine the angle times the differential of the angle x. So using the chain rule there, so this becomes 4x plus 3 into negative sine x times 1, which is negative sine x, 4x plus 3 minus sine x, and 3 by negative sine x, this becomes 4x minus 3 sine x, whose answer there is C. Make sure we know how to differentiate, okay? Alright. So again, another common question. So it says here, a curve C with equation y equal to f of x has stationary point at negative 2, 5. Stationary points again. If f double prime, and f double prime is the second derivative, f double prime x is x to the power of 4 minus 15. That's the second derivative. Then the point negative 2, 5 is what kind of point? It's a stationary, so it can be maximum, it can be minimum. So when the point is negative 2, 5, so at the point negative 2, 5, we're going to substitute when x is negative 2, we're going to substitute x equal to negative 2 into your second derivative. Yeah? This becomes negative 2 in brackets raised to the power of 4 subtract 15. Negative 2 raised to the power of 4. That is 2 to the 4, 4 to the 8. That's 16. Subtract 15, which is 1. And when the second derivative, I use f double prime, is greater than 0, it tells us it is a minimum point. Whose answer there is D for that one. It's a minimum point. So common questions, we should know them, alright? Right. So the gradient function of the curve, so what is to find the gradient of that function? Again, we have to differentiate. So we have y is equal to sine into 2x squared plus 1. So you want to differentiate that. Let's make sure you can differentiate that function. So dy over dx will be what? The differential of sine the angle is cos the angle. Remember the chain rule times the differential of the angle. So this becomes cos 2x squared plus 1 times the differential of 2x squared plus 1, the differential of 2x will be 4x, and the differential of 1 is 0. So multiplying 4x by cos 2x squared plus 1. 4x cos 2x squared plus 1 will be your answer, which is A. Alright? Okay, so we're getting into some integration now. So we want to show that if the integral of common question as well of 6 plus 3x dx is 72, where a is greater than 2, then what is a? We have to find a, right? So how are we going to find it? So the trick with this question, you can integrate it, you can substitute a, you'll get an equation, which will be a quadratic equation, and you have to find a, which will take some time. It will take some time. So an easy approach when it comes to this question to find what is just to use trial and error. So you're going to try all the values to see which one will give you 72. Okay? So which one will give us 72? Let's try a equal to 6. So what we're going to do is integrate this function given. So the integral of 6 plus 3x will be, we drop the integral symbol and dx. So you're going to get the integral of 6x, so 6 will be 6x, plus the integral of 3x will be 3x squared over 2. We are going to maintain our limits, which are 2, and a is the upper limit, 2 is the lower. And if a is 6, let's try 6 please. I'm replacing a with 6 now. If a is 6, let's see when I use the limits into my result I obtain after I've integrated the function given, let me see if I'm going to get 72. So when a is 6, and replace a with 6, I'm going to get 6 times 6 plus 3 times 6 squared all over 2. And we know we have limits, this is the approach we take. Subtract, substitute the lower limit, 6 times 2 plus 3 times 2 in brackets squared all over 2. This becomes 36 plus 36 by 3, which is 108 divided by 2, which is 54. Subtract 12 plus 2 squared is 4, 4 by 3 is 12, 12 divided by 2 is 6. So I'm going to get 36 plus 54 is 90. Subtract 18, which will give me 72, yeah? So I got 72, which means that the value of A is 6, alright? So we can use trial and error here to help us because we know it's a multiple choice, looking at time. So with this question, of course, if you see this question, the answer is automatically 6. So look, make sure it's the exact question. If not, we can use this approach to help us to find using trial and error. Alright, let's look at the next. We want to integrate that function, which is a composite function. Let's make sure we can integrate a composite function. So this will be let's integrate the integral of 2x minus 5 brackets cube dx. So you want to integrate a composite function. So how are we going to integrate a composite function? So we drop the integral symbol, we drop dx, we add 1 to our power, we divide by the new power, which is 4, and we multiply by 1 all over the differential of what is in brackets. Alright? So the inverse of the differential of what's in brackets. 1 all over the differential of what's in brackets plus your constant c. Anytime you integrate it, it's the indefinite integral, no limits. So after we integrate, we must add c. So this becomes what? 2x minus 5 to the power 4 over 4 times 1 all over the differential of 2x minus 5 is 2 plus c. So 1 times 2x minus 5 to the power 4 is 2x minus 5 to the power 4, and 4 by 2 will give us 8 plus c. Whose answer there is c. Alright? Making sure we can integrate the composite function. Common question. So, trig function. Let's integrate our trig functions. Common question again. Make sure you can recognize them. Make sure you know how to work it out if minor changes are made, right? So you have the integral of sine x minus cos x dx. So you want to integrate that. So we know the integral, we drop integral symbol dx, the integral of sine the angle is negative cos the angle times 1 over the differential of the angle. Very important. Making sure you know we implement that part of it when it comes to integrating. You always multiply by 1 over the differential of the angle. And we have now, let's find the integral of cos the angle. The integral of cos the angle is sine the angle times 1 over the differential of the angle plus. So the differential of x is 1, 1 divided by 1 is 1, 1 by minus cos x is minus cos x. So we all know the differential of sine x is minus cos x. But this part is important to know, right? Subtract, this is The differential of x is 1. 1 divided by 1 is 1. 1 by sine x is sine x. Plus. So we should have minus cos x minus sine x plus c, whose answer there is D. Common questions, okay? Right, so let's integrate that function. If y is equal to 3x squared plus cos x, then what is the integral of that function? So the integral of 3x squared plus cos x will be what? We have to integrate that dx. Then I know I'm going to drop the integral symbol dx. So I'm going to integrate 3x squared. So I add 1 to my power, I divide by my new power, plus the integral of cos the angle is sine the angle times 1 over the differential of the angle plus. So you're going to get here 3 into 3 is 1x cubed plus the differential of x is 1, or 1 divided by 1 is 1, 1 by sine x is sine x plus x cubed plus sine x plus c. See these questions, easy marks, easy mark in the bag, right? To help you to achieve at least 40 out of 45 in that multiple choice. Alright, so let's look at the next. Right, let's find the integral. This time we have some limits. The integral of 1 plus x squared between the limits of 1 and 2. Alright, so let's integrate that. Of course, to integrate that, we drop our integral symbol dx. You have limits, so you have to maintain the limits throughout your solution, and of course, we work towards achieving a result, a value. So this will be, let's integrate. Drop integral symbol dx. So the integral of 1 is x. The integral of x is x squared over 2. The integral of x squared is x cubed all over 3. I add 1 to the power, divide by the new power, remember that? And the integral of the constant, 1 in this case is going to be x. Good? Of course, I maintain my limits. And now let me substitute my upper limit into the result after I've integrated. Subtract, let me substitute my lower limit into the result after I've integrated. So this becomes what? 2 plus 2 in brackets squared all over 2 plus 2 in brackets cube all over 3. Subtract, let me substitute the lower limit now. 1 plus 1 in brackets squared over 2 plus 1 in brackets cube all over 3. So we're going to get here 2 plus 2 squared is 4. 4 divided by 2 is 2 plus 2 cubed will give us 8 all over 3. Subtract, this is 1 plus 1 squared is 1 all over 2. That's a half. 1 cubed, that's 1 all over 3. So we're going to get 2 plus 2 is 4. So it's 4 plus 8 all over 3. LCM 3. 1 into 3 is 3. 3 by 4 is 12. 3 into 3 is 1. 1 by 8 is 8. Subtract. Put in 1 over 1. So I'm going to simply say, I'm going to find the LCM one time. 6. 1 into 6 is 6. 6 by 1 is 6. 2 into 6 is 3. 3 by 1 is 3. 3 into 6 is 2. 2 by 1 is 2. So we get here 20 all over 3. Subtract 9 plus 11 all over 6. So what is 20 all over 3? Subtract 11 all over 6 again. If you want to make, of course, you're going to make the denominators the same. You have to find the LCM. So I'll use this approach. Multiply 3 by 2. And what I do to the denominator, I do the same to my numerator. Multiply 20 by 2, which will give me 40 all over 6. Subtract 11 all over 6. And 11 from 40 will give me what? So once my denominators are the same, I can simply subtract my numerators, which will give me 29 all over 6. Which is the same as 6 to the 29 is 4 remainder 5. Whose answer there is C. So make sure you know how to work it out, alright? Alright, let's look at the next. Must bring a question involving area and volume, right? So you should know how to find the volume of a solid. Volume of revolution. When you're dealing with integration, you should know how to find the area under a curve. So the region bounded by the curve, y equal to x squared, the x-axis and the lines x equal to 0 and x equal to 1 is rotated about the x-axis. What is the volume of the solid generated? So to find the volume, let's assume this is my curve, y equal to x squared. It is bounded by the x-axis. The lines x equal to 0, this is the line x equal to 0, which is your y-axis. The line x equal to 1, let's assume this is x equal to 1 here. A vertical line passing through 1. And this region here is rotated. Good? They want us to find the volume of revolutions. To find volume, it is pi, the integral between the two limits, y squared dx. So you have to make sure with that formula to find the volume of revolution. So this is pi, the integral between the limits 0 and 1, y squared. Y is x squared. So this is x squared all squared dx. So this will then simplify to become pi between the limits 0 and 1, x squared all squared is x to the power 4 dx. Whose answer there will be D. Alright, let's look at this one. What is the region R enclosed by the x-axis? The curve y equal to x squared plus 2 on the lines x equal to 0 and x equal to 1. What is the area of R? So area under the curve, right? So you'll have here alright, of course, same region. Same lines, x equal to 0, we have vertical line, the y-axis, x equal to 1, the x-axis, and of course you have the curve. Let's write this time, y equal to minus x squared plus 2. You want to find the area. So to find the area, it is the integral of y dx between the limits a and b. That's your formula, make sure you know your formula. So your limits are 0 and 1. Y will be negative x squared plus 2 dx. So you want to integrate that between the limits 0 and 1. And let's see what value we're going to get to represent the area under the curve. So this will be what? Drop integral symbol and dx. Let me integrate negative x squared plus 2, negative x cubed all over 3 plus the integral of a constant 2 is 2x between the limits 0 and 1. So let me substitute my upper and lower limits. This is negative 1 in brackets cube all over 3. So only subtraction sign. You replace 1, x and 1 in brackets cube all over 3 plus 2 times 1. subtract, this is negative 0 in brackets cube all over 3 plus 2 times 0. This becomes negative 1 over 3 plus 2. So 1 cube is 1, so you have that negative sign in front of it, so it's negative a third plus 2. Subtract 0. So everything in that bracket, second bracket, will be 0. So negative a third plus 2 is what? Negative a third plus 2 over 1. The LCM is 3. 3 into 3 is 1. 1 by negative 1 is negative 1 plus 1 into 3 is 3. 3 by 2 is 6. So we get 5 all over 3. So the answer there is B. Okay? So let's see. Right, so next, another very common question. Very, very common question. Let's look at that one. So that will be, so we have, if x is equal to the integral between the limits a and b f of x dx, and a is less than c, which is less than b, then what is x? Very common question, right? Well, what this is saying here, it's saying here, if you have this function, was that a curve? Let's assume that this is A, this is C, and that's B. Right? So A is less than C, C is less than B. And they want us to determine what is X. So we have two regions here, so you want to find the integral of this region, the integral of that region, the integral of this region between the limits a and c, the integral of this region between the limits c and b, and we add the two. Keeping in mind, this is the lower, this is the upper limit here, and for this region, this is the lower, this is the upper limit. So this will be, if it's y equal to fx, this will be the integral between the limits a and c, f of x dx, so integrate to get the area of this region under the curve for this region, plus the integral between c and b. C is the lower limit, b is the upper limit of your function f of x dx. Alright, so that's what we're looking at there, whose answer is C. Okay? Alright, so this will bring me to the end. I know it's a lot. So I'm going to end the session now. Again, just review some questions on probability stats. They'll bring back probably about 3 or 4 questions on those. So make sure you look at some questions on probability stats. But the questions from 1 all the way up to your integration, differentiation, make sure you can answer those questions well, alright? So, a number of these questions will be repeated questions. These are some of the common questions we expect to see. Please make sure you look at the video again and ensure you can work them out before you enter that exam tomorrow. So, wishing everyone all the best in your exam tomorrow, and let's work towards achieving a distinction in your Addmath, alright? So, all the best everyone. Take care. Have a good night.